So your question asks you to build a model to demonstrate the neutral compound of, I want you to make it look like this one that's up here, these two things. And so the first thing you need to do is you need to see, is it ionic or is it covalent, which we haven't talked about. So let's remember a couple of things. Ionic is between a metal and a non-metal. All right, there's one thing. The next thing I need to know is I am going to gain or lose electrons. I use oxidation numbers. I have to balance the charges. Okay. And then, of course, when you name it, you're going to do the metal plus the non-metal and add "-ide" on the non-metal. And so let's look at a few of these real quick, just to see what I have. And so the first one I'm going to look at is I'm going to look at sodium and I'm going to look at chlorine. So if you look at your periodic table, you can see that sodium has a 1 plus charge, chlorine has a 1 minus charge. Are these balanced? Yes, they're balanced. And so it asks you to put it in a model that looks like this, which we haven't really talked about, but basically it's circles going through and touching. So if I were to draw this with the valence electrons, Na has 1, chlorine has 7, and this just transfers over here. And so I could demonstrate that in a circle. So I have Na1 plus, Cl1 minus. That's what it would look like. Where it's touching is where I am transferring the valence electron. And so that's an example of that one. Let's look at aluminum, which is 3 plus, and fluorine, which is 1 minus. Are these charges balanced, first of all? No, they're not. How can we make them balanced? Add 2 more fluorines. We have 3 positives and 3 negatives. Then I'm going to draw the valence electrons. Al has 1, 2, 3. Fluorine has 7. So this one comes here. This one comes here. Remember, I'm making that full octet. And this one will come here. Now, I don't want this to be your final answer. I want you to draw it like it should be. And so when I draw it, I do F1 minus. Okay, how many aluminums is this F touching? It's only touching 1. It's just sharing it with 1. So Al3 plus. Okay. Then I need, this aluminum is actually touching all 3 of these fluorines. So I'm going to have 1 here, and then 1 here. And so if you notice, the fluorines are not touching each other. The only reason they're touching the aluminum is because they are sharing. Okay, and this is an ionic bond. And so that's going to get us into what we are about to talk about now. And we are about to talk about covalent bonds. All right, and so a covalent bond, it says, in covalent bonding, atoms still want to achieve stability by having a full energy level, or a full octet. So atoms here are going to be shared. A electrons. They share. So co means to share. They share the outside electrons. And notice it happens between a nonmetal and a nonmetal. That's why it's important for us. The first thing we need to determine if it's a metal and a nonmetal or a nonmetal and a nonmetal. And so let's look at one example. All right, chlorine. Chlorine can form a covalent bond with itself. Let's look at chlorine. When we look at our periodic table, chlorine has 7 valence electrons. Okay, if I want to bond chlorine with another chlorine, you're not going to be responsible for drawing these diagrams this year. I'm just showing you so that you understand. Okay, and so this is what the Lewis dot would look like. And so if we watch, this one has 7, I need 8. I'm going to circle that. Now notice I've got 1 pink, 7 blues. I come over here and circle the pink. They have shared 1 pair. Okay, they have shared that 1 pair. And so when we write shared pairs, we're just going to write Cl, Cl. This indicates that 1 pair is shared. So as we go through the PowerPoint, how will they become stable? Each chlorine wants to get 1 electron to achieve 8. They're not going to give up an electron because I'm not making an ionic bond. So they can share. They move closer and they share. So 1 has 8. Their octet is achieved by each atom sharing the electron pair in the middle. This is your bonding pair. It's a single bonding pair. It's a single bond, which is going to be abbreviated with a dash. Okay, this is going to be a chlorine molecule. Cl2 is a chlorine molecule, and we'll call it something else in a second. All right, as we move back to our notes, this was a covalent bond because I have a nonmetal and a nonmetal. So my formula for this would be Cl2, and I would call it a chlorine molecule because it is 2 of the same element. And let's look at oxygen. Oxygen has 6 valence electrons. I draw another. Let me actually move these 2 over here. So these are non-existent. Okay. All right, I'm going to draw another oxygen. 1, 2, 3, 4, 5, 6. Can you see how they will pair? And now I have 8 over here. And I have 8 over here. And so how many pairs did they share? They actually share 2 pairs. So it would be abbreviated like this. And that's a double bond, which you'll learn more about when you get to chemistry. Your formula is going to be O2. And again, because it's just 1, it's going to be an oxygen molecule. This is a covalent bond. All right, let's come back over here. So same concept. Each atom has 2 unpaired. They're going to move together like that. So they have 6 valence electrons plus the 2 that they're sharing. It's going to be a double bond. Right. How do we name covalent compounds? Again, we're going to use "-ide" at the end of the second element. In this one, when we write the name, we're going to actually use numerical prefixes. On both element names to show how many there are. Okay. So compounds made with more than one element. So up here, I didn't do this because these are the same element. I need you to copy down these prefixes in this chart right here to make sure that you understand them. So 1 would be mono, 2 would be di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 is deca. Make sure you copy these so that you don't get confused with deci and all of those. All right, so if we look at these examples of N and O. Okay, and this is on the back of your note sheet. So I have nitrogen monoxide. Again, I write the name of the first one, and then I list the second one, okay? Nitrogen monoxide, I have 1 oxygen. It says in most cases, mono is understood on the first element or sometimes even on the second element, all right? But if I have just an N and an O, I'm gonna put mono on the second element. The second one would be nitrogen dioxide. Di means 2. Next one, dinitrogen oxide. So if you see on the third one, because I have a prefix on the first one, I don't have to put monoxide. Then you have dinitrogen tetroxide, and then you have dinitrogen pentoxide. And so for these, you're not having to figure out the ionic charge on them. And so writing the formula is actually pretty easy because you just have to memorize the prefixes. So let's go and look at the next few things. All right, so select the correct name for each. So if I have SiCl4, all right, I have SiCl4, which one would be right? First thing you need to do is you need to tell me if it's a metal and a nonmetal or 2 nonmetals. And so I know that silicone is actually a metalloid, but it's to the right. So we are going to call it silicone tetrachloride. Your next one is phosphorus pentoxide. I'm sorry, phosphorus and oxygen. And the name of that would be diphosphorus pentoxide. And then your last one, you have ClO2O7. And the answer for that would be dichlorine heptoxide. So all of these are covalent bonds. Be careful and make sure you check to see if it's a metal and a nonmetal or 2 nonmetals. All right, now your turn to name them without anything. So I want you to pause the video and I want you to write down all the names. Then I want you to come back and check your answers. So first one's carbon dioxide, dinitrogen trioxide, boron trifluoride, silicone dioxide, silicone tetraiodide, and then diarsenic pentoxide. Now I want you to write the formulas from the names. And so when we write the names or the formulas, we need to take into consideration what are the prefixes telling us. So if we have phosphorus, pentachloride, we'll have PCl5. Dinitrogen trioxide would be N2O3. Then sulfur hexafluoride would be SF6. And then we get into properties of covalent bonds. And so covalent bonds have low melting and boiling points. They're weaker than an ionic bond because they don't have that positive and negative pull. They're not going to conduct electricity, so there's no ions to break apart, so there's not going to be charges. They're not going to dissolve well in water, okay? And so the next thing I want you to do is I want you to finish your worksheet where you're writing the formulas of each of the compounds. If you have questions, make sure you ask.